In this lesson, I will explain to you KFold cross-validation with the help of a project which we use in Python. So first of all, I will introduce you what I have written here, then we will move ahead. So here you know that import numpy as np and matplotlib is for our plotting purposes. Here I have written these three classifiers: logistic regression, which we had discussed so many times, similarly SVM, support vector machine, and random forest classifier. Classifier is just like a model, so we are going to compare these three models in k-fold cross validation, which model we have to use in order to make our score or model well. And then here I have written from sklearn.datasets import load underscore digits. This data set we had used in our logistic regression model as well. Logistic regression, multi-class classification, same data we are going to use here. And as I have told you, whatever we import, we have to make the object. So digit load underscore digits, which is initialized by digits, we are going to use this. How we will make the object of these three classifiers, I will show you later on. So I hope this is clear to everyone. I am going to execute it, and here is the asterisk sign. It means it is working. In few seconds it will work. Meanwhile, I will explain to you the next step. Here I have written directory. Only you have to write down DRI in order to check what we have in our are in our data set. So this is our data set. When I will execute it, so you can see we have data, we have images, target underscore names. But in this project, we will use this target and we will use data. So what is actually inside the data, what is in target, I will show you. But if you want, you can check the other as well. So here in our data set, there are 1797 records, and 8 by 8 is the image dimension. What is the meaning of it? I will explain to you again. So first we want to check data. So digits dot data, and as I said, we have 1797 records. So whatever you want, you can write down here and check between this from 0 to this number. When I will execute it, you will see here this is the 8 by 8 image. If you will count this will equal to 64, because 8 multiplied by 8 is equal to 64, but this is in the form of 1D array and in the numerical form. Okay, now if you want to check, the second is image digit underscore image. If you want to check some particular image, you have to write down only one numerical value here, 0, 1, 2, whatever you want. When I will execute it again, you will see the output in the form of 2D array. Make it 100 and check, and see, now we have another 2D array. This is, but if you want to check from 0 to 5, you have to write down like this. If you want to check from 0 to 100, as we have 1797, this is the record. So whatever number you can write down here and check. But here again, you can see when we check the data is in the form of 1D array and 64 numerical values are here. If we want to check the image, again it is the 2D array, but there are 64 values. We want to check the image. If you want to check the image, you have to use the mat show function. So how you have to write down, this is the syntax: plt.gray, then plt.mat show digits.images. And when I want to check the image which is on 199, when I will execute it, you will see the images here. This image is here because we have used person matplotlib inline function. So if you want, you can change the number, make it 299, as we have 1797 records. So whatever you want to check, you can see this is the image, and these are the dimension, 8 by 8 dimension, which is equal to 64. Then you have to find out what number this is, from starting from 0 to 8, right? Okay, here now we are going to split our data into testing and training. So 1797 records we have. I said 20% I want to keep for my testing data and 80% I will train my data. So what you have to do from sklearn, you have to import train test split, and see train test split in parentheses. What you have to write down, your data, our data is digits, and this is the column. As I told you that we will use data and target, so our data name is digits dot data comma digits dot target, and test size I said 20%. It's up to you. If you want, just make it 30% testing or 10%, whatever you want. What this will give us, it will give us x train, x test, y train, and y test. So I'm going to execute it, and it is executed successfully. Now is this, as I have told you that we are going to use three different model or three different classifiers to check which classifier will give us the more accurate result if we use KFold. So this is the logistic regression, right? So here I will show you one more time. We had imported logistic regression, imported SVC, imported this. So here we are going to make the model for these three. Logistic regression is equal to logistic regression, and this is the fit. Keep in mind, when we use the fit here, you have to write down train, x train and y train, but when we use the score or predict, we have to use x test and y test, right? Here in this bracket or parenthesis, I did not mention anything, but if you want, you can write down some parameters. These parameter, if you want, you can go to the scikit-learn and learn and read it there. In this way you will learn more. So if I will check the score of this, if I want to use logistic regression, so you will see 0.969. Our model is 96% accurate. If I will use support vector machine on this project, what will be our score? Our score is 0.4646%, which is not good compared to the logistic regression. Now what about random forest? If you will see, only the classifier name is different, otherwise the rest of the lines are same. When I will execute it, so here you will see it is 0.98, means here you can pick which one, which model will give us more accurate results. So random forest, it is 98%. But here is one important thing, that when I will execute this, right, 20% is testing and 80% testing. It When I will re-execute it, whatever sample the system has provided 80%, it will change, because not the same number will come again and again. That is why our model will also, the output or score will also change. So see here, I am going to execute this one more time. Now our 80% data, which is the 80% of 1797 records of training, it will change. And when I see, keep in mind, this is 0.969. When I will execute it, this time is 0.958. Why? Because every time we will re-execute, the system will generate different sample number. Similarly, for support vector machine is 46%. So here we will get this time 47%. And for random forest, so see here it is 97%. Last time it was 98%. So if you will execute this again and again, this you will execute, every time this number will change. If you want that whatever number is coming, you have to keep that number. So what you have to do at the end, you have to write down random underscore state is equal to 4. Again, it is not necessary you have to write down 4. You can write down 5, 6. If you do not know what is the meaning of it, you can watch my previous video, it will really help you. But if you will write down random underscore state, suppose here I said 4, when I will execute it, this is your homework you have to do. When you will execute it, right, whatever sample number will system will generate, 80% for the training data, it will remains the same, right? But here on the basis of these three, we can say this model is best, but we have to use the KFold. So how you have to write down the syntax? Again, you have to import KFold from sklearn.model selection KFold. Here is the KFold. We have to create the object for this. So KFold, I said here, I said is 4. What is the meaning of it? Whatever data we have to divide into 4 equal parts, our data. So I am going to execute it. First I will give you example, then we will work on our actual data. So this is the example, how you have to write down the syntax for train underscore index, train test underscore index. See, I have used the word index, and I will show you what is the meaning of it when I will execute it. in kf.split. Suppose here we have these 12 numbers. I said here split is 4. Again, this is not constant. It means you, if you want, you can divide your data into 10 equal parts, into 100 equal parts, into 50 or 10, whatever you want, right? But you do not have to write down k is equal to 4. You have to write down n underscore splits is equal to 4. This is the proper syntax. So when I will execute it, see print train index test index, when I will execute it, you will see the data is divided into 4 equal parts. So index means even though this number is from 1 to 12, but it is count from 0 1 2, that is the meaning of index. So 0 1 2 and the last is 11. So it will divide. See, the first three are our testing data, first fold, and then second this and this, from 3 to 11 our training data. In this one is our testing data, and this one, the first, third and fourth one, is our training data. In third fold, the these three numbers are our testing, remaining three folds are our training data. In this way you will see each and every number has a chance to become as a test member or as a train member. In this way our result will be more accurate, right? So I hope the concept is clear of KFold. Now we will move on to our actual data. Here I said define get underscore score, because we are comparing three different classifier: logistic, regression, SVM, and the last one is random forest. So get score model, what model we are using: X train, X test, Y train, Y test. So see this thing, and whatever I have written here, these thing, these this cell 14 15 and 16, here I am using three lines. So instead of writing this is the another way to write down for the score. And then model dot fit, in fit again I will show you that you have to write down train, what return, what value it should return, model dot score. When I will execute it, it is executed successfully, right? Now we will get our score. So here this one I have already imported this one k. I will show you here. Import k fold, n is equal to 4, right? So this one and this one actually both are same, but I am using import stratified k fold. What is the meaning of stratified k fold? Actually both are same, right? But here suppose sometimes we have different kinds of data, some numbers are low, some are medium, some are high. So it will if we are using the stratified k-fold, it will divide our data uniformly. Means suppose if the system is picking three numbers as a test from the low numbers, here will be the training set, and so on. So here instead of 4 I am using 3, only to show you that it is not necessary that you can divide your data into 4 folds. You can divide into 100 folds, 10 folds, 15 folds. So I am using 3. So these and this both are same. I am using this. Okay, now move on to our next cell. In next cell, I have written a long coding, but this is very easy coding. Actually, this coding is only to explain you what is going on. Otherwise, in scikit-learn, I will show you after this. There is a only one line coding you have to use in KFold cross validation, but this is just for your understanding. As we are calculating the score of logistic, SVM, and random forest, that is why I have written these arrays here. And then this is the syntax for train underscore index, test underscore index, which I had showed you earlier in folds dot split. This is your data. On this we have to work data digits dot target, right? And then this is the output X train. If you will see very slowly, it is very easy. Digits dot data, digits dot target, these two we are using in our project. So here train index, digit data, test index, exactly these are same, but these are belongings to data and target, right? So see, if I say I want to print the score of these three, logistic, SVM, and R, that is why I have used the word print. Get a score logistic, get a score, and get a score, right? And here are our four parameters. I will show you one more time. Exactly same things are on the parenthesis. If you will write down, then it will be much more easy to understand. So here, see, you can see what is going on here. We are getting some numbers. So what is the meaning of these numbers, right? Okay, as I have told you that I had divided my data into three different folds. So first three, these are the scores of the logistic. And our data is divided into three folds. For first fold, whatever is our testing or training, this is the score of logistic one. This is the second, this is the third. You can add and take the mean. Similarly, next three, these are the for the SVM, and these three are the scores of our last random forest. Okay, now here instead of printing, I said score underscore logistics dot append. Everything is same, right? Here I have split this in different cell, this in different cell. If you want, you can write down all this coding in one cell. Remove this pound sign or hashtag. This will be the part of this, and everything is there. You can see, right? So here in the previous coding, I had used the word print, but when I will execute it, it is executed successfully. Now we can run this score logistic, score SVM, whatever I had used here, these three, right? And you can see the score. When I will execute it, so this, do not worry why we have these three, because this is the score of our first fold. This is the second fold. This is the third fold, because we said our K is equal to 3. So that is why these are the scores. Execute for the SVM. As you know, SVM results are not good. So this is for the first fold, second fold, third fold, and this is for the random forest. And you can see, if you want uh, uh, to make a decision which model we have to use or which classifier we have to use, so it is obvious that random fire has more score, right? But sometimes these scores are so close to each other. So what you have to do here, I said in the random classifier, if I will make it, I'm going to tune this parameter. So see, the number will change. This one here in logistic, and then in SVM, and then for this is for the random forest. So we can say 93, here is 94, 94, here is 1993. Sometimes it happens the number are so close, so what you have to do, take the average of these three, right? This separately, and see which score is highest. Then you have to decide which one you have to use. But here we have make comparison between three different classifiers for the KFold. But if you do not want to use this and this, whatever, suppose if you want to use only one classifier and you want to make decision, so yes, you can tune your parameter here. Okay, one more thing before going ahead, that as I have told you that this one is only for the explanation. In real life, you do not have to write this long coding. Again, it is easy. But in sklearn, we have a library cross val score. So from scikit-learn model selection, you have to import cross val score. I am going to execute it right in one line. See, in one line, and then you can find out the score of logistic regression. You this is C cross well score, same whatever I have written here. Here is the logistic regression, here is the SVC, here is random forest, and here everything is same. Digits dot data, because we are considering data and target I will show you here, right? Okay, so when I will execute it, you will see this is for the logistic regression 89, 94, and 90. So it is same 89, 94, and 90, right? So this is, again, this is just for explanation. Only you have to write down this line and get your score. And this is for the SVM support vector machine, and the score will be low. You know, we had seen so many times. See, 39%, 14. So this is not good. This classifier is not good. Now we will move to the random forest, which will give us, I think, the more better output. So see here, 89, 91%, 94, 94, 92, and 90. More or less they are good, but here this one is more preferable out of these three, right? If you do not want to use these three, you want to use only random forest, then you had to change your tuning. If I say estimators, my forests or my roots are suppose 40, here I said 50. So what is the output? We can check. So here is C 91 and 92, and here is 95 and here is 92. So it is, I think the 50 is more better. Let's check for 30. So it depends. You do not have surety which you have to use, which parameter, but you have to tune, and then you have to decide on the basis of these parameters. It is a trial and error. Here is 93, this, and 92, right? So okay, check for 10. So 10 is low, right? So 50 or 30, and you can try 35 or 49 or 45, then you can find out the much best result. So I hope the concept of k-fold cross validation is clear. Please practice it. Subscribe to my channel. See you in the next lesson, and thank you.